Okay, I'm going to do some of the odd problems that you had for homework. So you had even problems on page 218, 92 to 106. I'm going to do some of the odd problems to help you study for this test. So number 91, you have the natural log of x equals -3. And we want to solve for x. Anytime we start with a logarithm like we do right here, to get rid of the logarithm, we have to do the opposite of a logarithm, which is an exponent. So we're going to exponentiate. And you don't have to really memorize this word, but I want you to know what it is. Whoops, I kind of ran out of room. There should be an E there. What that means. That means that this side and this side are now going to become exponents. Okay, so then what's the base? Well, the base is going to be E, because natural log is really log base E. So E raised, and let me use a different color here so you can see, raised to the natural log of x equals E raised to the -3rd power. And as you can see, that these now become our exponents. Well, why did I do that? Because e to the natural log of e to the raised to the natural log of anything is 1. 1 times x. Let me actually take this a step further. So, okay, so what? So we started with something here. That became our exponent. We exponentiated. Well, why is that useful in solving for x? Well, using the power rule, we can bring that down, right? That's just x times, oops, I'm sorry. Let me just erase that. That's the same as the natural log of x times e from the power rule. Okay, well, why is that useful? Well, the natural log of x times e, natural log times e, well, e times the natural log of x, that's just 1. You're left with just x here. They cancel each other out. And on the quiz tomorrow, you're not going to need a calculator. You can just leave it as e to the -3rd or 1 over e cubed. Either way, it's going to give you the right answer. So that's number 91. 93. The natural log of 4x equals 2.1. Okay, the natural log of 4x equals 2.1. All right, well, what is that? I want to get x by itself. So I have to get rid of this natural log. How do I get rid of the natural log? Well, just like I said in the problem we did, but let me just take this a step further. The natural log is really log base e, right? And we know that e raised to the log base e is equal to 1. Just like, let's see, log base e of e equals 1. Why is that? E to what power gives me e? E to the first power gives me e. That's why the answer is 1. Well, why am I bothering explaining all of this? Because we're going to exponentiate again. These now are going to turn into our exponents. So I'm just going to e to both sides, and e raised to the natural log of 4x equals e to the 2.1. And e to the natural log of anything, e to the natural log, it cancels out. You're left with just 4x over here equals e to the 2.1. You're not done. You want to get x by itself, so you're going to divide both sides by 4 like you would with any other algebra problem. So it's going to be x equals e to the 2.1 over 4. You can just leave it like that. If you have a calculator, you want to give me the decimal, great. If not, you can leave it just like that. All right, I'm going to do number 95 in your book. Number 95 is log base 5 of 3x plus 2 equals log base 5 of 6 minus x. Log base 5 of 6 minus x. Okay, let me see if I can write it smaller because I want you guys to see it all on one line. Log base 5 of 3x plus 2 equals log base 5 of 6 minus x. If you look at both sides, I have log base 5 of something on this side and log base 5 of something on this side. And if I have log with the same base on either side, then I don't have to use them. I can essentially cancel them out, and I'm left with 3x plus 2 equals 6 minus x. And I can just solve for x here. So what do I have here? 4x equals 4, x equals 1. Now, why didn't I exponentiate? Well, because I could have, and essentially that's how you cancel them out. But because I had a log on both sides, not like the other problems, I didn't really have to go through that. But here, let me show you something. Let me just move this out of the way. So again, if I wanted to, I could exponentiate 5 raised to the log to the 5th power, 3x plus 2, equals 5 log base 5, 6x minus x. And 5 raised to the log base 5, well, that equals 1. So we're back to this step right here. Okay, let's do number 97 in the book. Okay, number 97. Oops. Negative 2 plus 2 times the natural log of 3x. So negative 2 plus 2 times the natural log of 3x equals 17. Okay, I want to get x by itself. That's my goal every time. I'm going to add 2 to both sides first. Don't attack the natural log. Get everything farthest away from x out of the way first. So I'm going to add 2 to both sides. So now I'm left with 2 natural log of 3x equals 19. So I added 2 to both sides. Next, let's get rid of this 2 by dividing both sides by 2. So now I have the natural log of 3x equals 19 over 2. Okay. And finally, now let's get rid of the natural log. And we know that we just have to exponentiate and use e. So e raised to the natural log of 3x equals e raised to the 19 over 2. Or if you want to call it 9.5, it's the same thing. E to the 9.5 power. Okay. E and natural log cancel out. I'm left with 3x equals e to the 19 over 2, which by the way is the same as e equals e raised to the 9.5 power. And finally, x equals e to the 9.5 over 3. And we're done, because now we have x by itself. Okay, let's take a look at number 99. Seven times the log base 4, so 7 times log base 4 of 0.06 x equals 12. Okay, again, what's my goal here? To get x by itself. First thing I'm going to do is get rid of the 7. So I'm going to divide both sides by 7. So that's going to give me log base 4 of 0.06x equals 12 over 7. And then log base 4 means I'm good. So this is going to be an exponent, and this is going to be an exponent. And what's the base? This determines the base, the number right here. So here it's 4. So 4 raised to the log base 4 of 0.06x equals 4 raised to the 12 over 7 power. And these cancel out, and I'm left with 0.06x equals 4 to the 12 over 7 power. And the last thing I'm going to do is divide both sides by 0.06. So x equals 4 to the 12 over 7th power divided by 0.06. And let's actually use our calculator for this one. So 4 raised to the 12 7th power divided by 0.06. And that's 179.45. Okay, hopefully these examples help you. See you tomorrow. Bye-bye.